अच्छा चलो क्विक रिकैप प्रॉब्ली चैप्टर ही खत्म हो जाएगा आज। रिकैप ये कि यू हैव orders, right? So order of reaction, your rate of reaction depends on the normally depends on the concentration of your reactants. ठीक है, it's A and B reacting together. So rate would be dependent on A and it will also be dependent on the concentration of B. और ये जो power होती है, that's the order. That shows how it's dependent, ठीक है? And your rate equation is you've got rate is dependent on the concentration of A and the concentration of B. The powers are the order of the reactant. Proportionality, if you get rid of that, you have to bring in a constant. That's your rate constant. And this over here is your rate equation. Order 1 ka matlab kya tha? Order 1 was that the rate is dependent on the concentration of a reactant, but the power is 1. That means it is directly proportional. You increase the concentration of A, the rate will proportionally increase. Okay, so this is a directly proportional relationship. Order 1 is A's concentration increases, the rate also increases. ठीक है, और दो graphs थे, तो the other graph was that in order 1, if the relationship is order 1, so, so the second graph was with respect to time, okay, the reactant concentration, over time it decreases, right? So if it decreases, the reaction slows down, so the curve becomes less steep and less steep, right? So this is order 1. Okay, as the reactant gets used up, the rate of the reaction becomes, it takes longer and longer time for the reaction to finish. It's going to slow down as the concentration of the reactant increases, ठीक है? और इसमें था कि order 1 में there's a thing called half-life. The half-life remains constant, which means half-life is the time required for the concentration to decrease by half. So every time it is the same amount of time that's required for the concentration to decrease by half, and it is always constant. ठीक है? Order 1 के बारे में एक और चीज़ है, which we'll talk about later on. Order 0 was when the rate is order 0. That means it's not dependent on the concentration of A. That means whatever the concentration of A is, anything to the power 0 is always 1. So the rate is not dependent on the concentration of A. You keep on increasing concentration of A, the rate, nothing happens to it. ठीक है? or time के respect से, if A is getting used up, the speed will remain exactly constant. It's going to get used up at the same rate. The rate is not going to change. The gradient of this curve is basically rate. Or फिर order 2 था. Order 2 was that it was too sensitive to the concentration of A. That meant that your rate uh, you double the concentration of A, the rate will increase 4 times. You half the concentration of A, the rate will decrease 4 times. So it's a squared relationship. It's too sensitive. तो वो rising curve होगी, the rate will not proportionally increase, it will increase exponentially. ठीक है? And as with respect to time, as the concentration of the reactant gets used up, the reaction will slow down, but it's going to slow down by a much bigger margin, right? Half होगा तो the rate will slow down, it's going to decrease by 1/4. So every time it takes a longer and longer time for the concentration to decrease by half. और इसके अंदर the half life always doubles. ठीक है, this is order 2. So last time we did mechanisms. तो आज जो करना ना, what we're going to do is कि many mechanisms I had explained to you how the order works. I said now what we're going to do in this one is that finding the rate, not the rate exactly, finding the order of a reaction in reactant होता है, order of a reactant in a rate equation experimentally. Okay, so this time we will deal The graphs हो गया था. The mechanism was given to us. Now we're going to talk about how to figure out this experimentally. ठीक है. तो इसका ना वो मैंने इसलिए I sent the worksheets क्योंकि data will just एक दो क्वेश्चंस पे कर लें ताकि नोट्स बन जाए. 1 सेकेंड. ये मैं वो वर्कशीट ओपन कर रहा हूँ. नहीं पता नहीं. 1 सेकेंड. अच्छा ये वाली ओपन की हुई है 2020 वाली. I'm just going to plug in some experimental data चाहिए. अच्छा, so anyways, you've got there's a reaction that's going on. So this is an example. So there's a reaction that's going on. It's 2NO gas. अच्छा, plus you've got O2 gas. And the product is 2NO2 gas. He gets 2NO2 gas. Now, there are two reactants. There is reactant number one, and this is reactant number two. Okay, you got two reactants. Now, your rate equation would be that the rate would depend on the concentration of NO, and it will be dependent on the concentration of O2. And you have no idea what the order is. So I'm just going to write A and B. And if I want to get rid of the proportionality, I'm going to introduce a rate constant, which is going to be K. So this is my rate equation. So I need to find out A and B. If they had given me the graph, if they had given me the half-life values, I would have figured out the order. If they had given me the mechanism, I would have been able to. The original equation is kind of irrelevant, right? You can remember when we were doing how to figure out the order with respect to mechanisms. I told you, well, the original equation is completely irrelevant. Okay, the rate depends on the slow step. So again, if you don't even know what the mechanism is, so you can't really figure out that way as well. So what is going to happen is they're going to give us some data, which is, yeah, they're going to do several experiments, and the initial concentrations are given. So for example, there is so NO. He's using different concentrations of NO and O2, right? Now in experiment number one, he uses zero point 0.1 mole per dm cube. Okay, mole per dm cube. This is, and this is also. So in experiment number one, okay, let's say this is experiment one. This is 0.100 mole per dm cube, and this is 0.05 mole per dm cube. And the initial rate is calculated, and that's mole per dm cube per second. The change in concentration with respect to time, so that is mole per dm cube per second. And this kind of but I have to explain this fact that whenever you try to compare experiments, when you try to compare rates of reactions of different experiments, you always measure initial rate. But because reactions slow down, okay? So you don't really measure the rate after 10 seconds or after 20 seconds. You always measure the initial rate, which is t is equal to 0. Because बाद में तो it's going to slow down anyways, right? So it's always measured at t is equal to 0 seconds. That's where you're going to try and measure the gradient. So for comparison, specifically for comparison between experiments, but also करना क्या? He's going to use different concentrations of NO and O2, and he's going to figure out what happens to the rate. If the rate doubles, if you double concentration of NO, that's order one. If you double the concentration of NO and the rate quadruples, that's order two. If you double the concentration of NO and the rate does not change, that means it's order zero. Okay. So for comparison purpose, it's always the initial rate that is measured. ठीक है कोई भी experiment होगा when you're trying to measure the rate, it's not the rate that's going to be measured at this point. ठीक है या after 20 seconds, they're not going to measure the rate. It's always you just start with the gradient. That's the gradient that's always measured. ठीक है I'm going to इधर मैं एक line भी draw कर लेता हूँ. It's always the gradient at t00, that is always measured. So, ये that's your initial rate. And it's change in concentration with respect to time. I mean, normally it's any change with respect to time. Change in concentration with respect to time, so it could be mole per dm cube per second. ठीक है यहाँ तक क्लियर है सारा. इनिशियल रेट वाली बात क्लियर है उमर. आवा एनालिसिस क्लियर.
Yes, sir.
ठीक है वापस उस पर आ जाओ. I say experimentally is kind of easy. I'm just going to plug in some data. He is going to do another experiment. As a first experiment, the initial rate that he measured was 3.5 mole per dm cube per second. So that's a 3.4. And then he does another experiment, and he's going to see if he changes the concentration, what will be the effect. So what he does in the second experiment is he takes 0.05. So he's the concentration of NO has been halved, and the concentration of O2 remains exactly the same. And what he has noticed is that the rate is now what it's 0.875. Okay. And then he does another experiment. He does experiment number 3. And this time he keeps the concentration of NO as 0.05. And he doubles the concentration of O2. And when he does that, the rate is now 1.75 mole per dm cube per second. I said, that's it. So I said, now they won't ask you to do any math on this. By just looking at it, you should be able to predict what the rate is. Okay, by just doing simple math, not simple math, but just looking at it, okay, you will get an idea about the orders. So now if I compare, this is how you're going to write the answer. So if I compare experiments 1 and 2, what is happening? What's happening is that the concentration of NO has been halved, right? I said so and O2 is kept constant, so that is not playing any role on in the rate of reaction. I mean, that variable is being kept constant, right? So so he's changing this variable and he's looking at the effect that will have on the rate of the reaction. So what has happened is if you compare experiment 1 and 2, तो क्या effect is this has been halved. I said, can you wait 1 second? अच्छा सॉरी, हेलो आवाज आ रही है? हेलो, ऊपर आवाज आ रही है बाबा, हालांकि ये भी।
Yes, sir.
अच्छा, एक्सपेरिमेंट 1 and 2, ठीक है। इफ यू कंपेयर एक्सपेरिमेंट 1 and 2, तो ये 3.5 से इट्स डिक्रीजिंग टू व्हाट, इट्स डिक्रीजिंग टू 0.875, राइट? So what does that mean? What is the factor by which, I mean, you have to figure out what the factor is, right? Factor easily पता लग जाता है. What you're just going to do is take 0.875 and divide that by 3.5. So again, if you do this on your calculator, what do you get? You 0.875 divided by, अच्छा, divided by 3.5. So 0.875 divided by 3.5. ये मैंने क्या किया? 0.875 divided by 3. Yeah, I'm going to get exactly 0.25, right? Which is 1 by 4. So that's 1 by 4. The constant relationship बनी है. This is not directly proportional. This is not order one. I've halved this, and the rate on the other side has decreased by 1 by 4. So that's a squared relationship. That means it's order two. So if you compare experiments 1 and 2, the concentration of NO, so the NO concentration decreases by half. So it decreases by half, and rate decreases by 1 by 4. Hence, the order with respect to NO's concentration, the effect that NO is having, that's order 2. ठीक है सारों को, is this clear? But clear, Mama, Hala, is this clear? Clear है सारों को कि order किस तरह निकले? आवाज आ रही है मामा, हाला, ऊपर?
Yes, sir.
अच्छा, तो इसी तरह you have to figure out the order with respect to O2 as well, right? So when you want to figure out the order with respect to O2, so you want O2 and rate, right? You need to figure out. So you're going to just try and compare experiments where NO is going to be kept constant, so that you can identify the relationship between O2 and the rate, right? So, usme which experiment should I compare? So I'm going to compare experiments 2 and 3. Because the NO is kept constant, so that's not going to have any effect on the rate of the reaction. This is being doubled. Or it's also being doubled, right? Both of them are being doubled, right? So if you compare experiments, which experiments 2 and 3, answer इसी तरह करोगे कि वो पूछेगा ना कि what's going to happen. So if you compare experiments 2 and experiments 3, so what is now happening is that ये तो same है. This is doubling, and this is also doubling. Because that is a directly proportional relationship. That means the order is 1. So experiments 2 and 3, NO concentration, what happens to it? It doubles. And the rate, or the initial rate, also doubles. So hence, order with respect to O2 is, or O2's concentration is 1. Which means कि ऊपर वाले में, this is basically rate is proportional to O2's concentration, and it's directly proportional. It's power 1. So yeah, it's order 2. That means rate is proportional to NO's concentration, and that's squared. ठीक है, ये clear? Is this thing clear? So this is the third way of finding out how the order of reaction varies with respect to time. And so up now what we're going to do is we're just going to do questions directly on the worksheet. Let me just open the worksheet. So you can see 20, that's 58. Copies are, that's the sort one. Second. So we're just going to do more questions. ये पहला वाला question we just did that. So we're just going to do the experimental method questions. One second. I say here's another one. I said there's going to be some that will be difficult as well. Now, the question that's on your screen, that's this question. There are two reactants over here. There is ammonia and there is ClO. So if I make the rate equation would be, that rate would be, if I bring in the constant as well. So it's it will be dependent on ammonia's concentration. And no idea what the order is, so that's A. And it will be dependent on ClO minus 1 concentration, and that's order B, right? So that's my rate equation. So now, if I look at the experiments, which experiments would I compare to figure out, let's say, ClO minus 1 order? Okay, now this one is going to be slightly more difficult. I want to figure out how ClO minus 1 affects the rate of reaction. So what I'm going to do is I'm going to try and change ClO minus 1, and I'm going to try and figure out what is the effect on the rate of the reaction. Lekin there's a problem. The problem is that I need to keep ammonia constant. Okay, I don't want ammonia to change so that I can know that because if ammonia changes, then I don't know whether this effect is being caused by ammonia or is it being caused by ClO minus 1. So what I need to know is I need to keep the other one constant. So give me so there's a problem now, which is I can't really figure out because this is also changing, so I can't really figure out whether the rate is being affected by ammonia or is it being affected by ClO minus 1. It is clear? How is this clear? Okay, we've got a problem over here. Hala clear है? ये बात clear है कि नहीं clear? हाला उमर आवाज आ रही है?
Yes, sir.
अच्छा तो इस वाले में ना the trouble is that you can't figure out ClO minus 1 order because I mean there's no experiment that directly tells you that. So what we'll do is we'll focus on ammonia then. Can we try and figure out what the order with respect to ammonia is? Can we figure out the ammonia and rate में क्या relationship is? Now that is possible because if you compare experiments 2 and 3, you would notice that ClO minus 1 is being kept constant. So that as a variable is now no longer part of the equation. This is being doubled. And what happens to your rate of reaction by just looking at it? It's increasing 4 times, right? So that clearly means तो पहला काम तो ये करते हैं कि if you compare experiments 2 and 3, let's say if you compare experiments 2 and 3, what's happening is that ammonia concentration is being doubled. And your rate increases 4 times. Like the order with respect to ammonia is 2. With respect to ammonia's concentration is 2. Okay, so you've done that. I said now, but the trouble still remains. So ammonia ka order you have figured out. That is 2. I'm like, the trouble is still there. That how do you figure out CLO minus 1? Because you're still stuck with the same problem, which is okay, there are no experiments where there's a direct relationship between CLO minus 1 and the rate. Because in all those experiments, ammonia is also changing. Okay, but the good thing is you know ammonia is ordered now. So what you can do is uske लिए you can either solve some math, which is you have this rate equation over here. So if you look at the rate equation, rate is what? It's ammonia's concentration, and that's order 2. We've figured that one out. CLO minus 1, we don't know what it is, so that is I mean that's B. तो आप ये कर सकते हो, what you can do is you can plug in values of 2 experiments. Into this rate equation and solve simultaneously. So plug in values of 2 experiments. And then solve experimentally, you simultaneously solve this. So experiment number 1 or 2 kilo values, I'm just going to plug them in this rate equation. So first one, the rate equation is 0.256. I don't know what the constant is. In the first experiment, ammonia's concentration is 0.1. And that's squared because I know what the order is. CLO minus 1 is 0.2. And that's power P. So that's the first experiment. Okay? Experiment number 1. I've plugged in the values in the rate equation. I'm going to plug in the values of experiment number 2. So उसमें the rate is 2.05. And you've got a rate constant and the initial constant and the ammonia concentration is 0.2, and that's going to be squared. And CLO minus 1 concentration is 0.4, and that's power B. So I'm going to simultaneously solve for B now. Okay. Simultaneously, how do you solve for B? There are two values. There's K. You get K, dono mein, you don't know what K is, and there's B, which is not known. We're basically looking for B. Now, K is a constant, so that means K would be exactly the same in both experiments. So if I plug in the K value for, I mean, if I make K the subject of the equation, it's going to look like this. That it's going to be 0.256. You can remember I'm making K over here the subject of the equation. So it's going to be 0.256 divided by 0.1 squared. And 0.2 power B. I'm going to take this K and I'm going to substitute this K into my second equation. So if I do that, what I'm going to get 2.05. If I plug in K over here, it's going to be 0.256. And there's 0.2 square and there's 0.4 B. And 0.256 will be divided by 0.1 squared. And 0.2 B. Now, simultaneously solving this, 0.256 divided by 0.1 squared. And 0.2 B. Now, simultaneously solving this, 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 simultaneo simultaneously solving this, I need some space, so I'm going to go over here. You got 2.05, and you're dividing it by 0.256. I'm going to bring this over here. I'm going to bring 0.2 and 0.1 to the other side as well, so that's going to become 0.2 and 0.1. And I'm going to make it whole squared. And I'm going to have 0.4b. And I'm going to have 0.2 b on the right side. I've rearranged the terms. Now I'm going to try and figure out what this is. Okay, on my calculator, it's going to be, so it's 2.05 divided by 0.256, that's around 8. I mean, this thing is around, that gives me 8. And so that's, the other thing is half squared. So 0.5, and that's into 0.5, and then multiplied by 8. This entire thing gives me 2. And 4 divided by 2 is also 2. So this side is 2 power b, right? So finally, after doing all this math, this is what I'm getting. And now it's quite easy to figure out what b is. So b क्या होगा? It's what is 2 to the power b that is equal to 2? Then that means b is obviously, it's obviously 1, because 2 to the power 1 is equal to 2, right? So that means after all this math, I've been able to figure out that the b over here is actually, it's actually going to be 1. ठीक है, 2 to the power 1 into होता है, ठीक है? So that's how I did that. So remember, again, I'm just going to recap everything, which is this question, man. You're going to have trouble in only this question where you won't be able to experimentally figure out the order in cases where you can't find a direct relationship between the date and CLO minus 1 in this case. Because beach में this is also changing, so you don't want that to, you don't want the other variables to change. So what I did was, I wasn't able to figure out CLO minus 1 initially, but I was able to figure out ammonia because there were experiments where CLO minus 1 was kept constant. It double हुआ, and this became 4 times. So I was able to figure out that this is order 2. But I wasn't able to figure out what the order of CLO minus 1 was. So करना क्या है? You got a partial rate equation now because you figured out that ammonia is order 2. You don't know what CLO minus 1 is. You don't know what this power is. So plug in the values of any 2 experiments. Experiment 1, experiment 2. Which I plug in kar di, and I took k of the first one. I made k the subject of the equation, the first one. And then I used that k and plugged it into the second equation. And once I solved all the sorry, math solved about what I eventually got at the end was I got 2 to the power b is equal to 2, which meant that b was 1. ये clear है सारों को? Is this clear?
Yes, sir.
ठीक है. अच्छा, अब now one thing is, it's just a 2-mark question. What they expect from you is that they don't actually expect all this math from you. ठीक है, but वो आपसे expect बताओ क्या करे? They're actually expecting you to figure this one out by just looking at the values. अच्छा, so can you do that? Can you figure out the order by just looking at the values? ठीक है, by just looking at the values, ठीक है, without doing all the math. So there's a way, but that's much harder. What you can do is, you know that this is order 2, right? Order 2 means that if you just look at experiments 1 and 2, this is doubling, right? So that means my rate would quadruple, right? It will become 4 times because order 2 means it's going to become 4 times. Remember, हमने ammonia का ना, we already figured out what the order is. So what is 4 times of 0.256? If I do 4 times of 0.256, now I'm trying to do this without doing all the math. So 0.256 multiplied by 4, and that gives me 1.024. So my rate should have been 1.024, right? So this is the effect of ammonia, which is order 2 in between experiments 1 and 2, right? But as you can see, my value for experiment number 2 is not 1.024, it's actually 2.05. That means it's actually doubling again, right? So ammonia ka effect, I've already included ammonia's effect. Ammonia would have increased the rate to 1.024. But as you can see that in experiment number 2, the rate is not coming out to be 1.024. It's actually doubling again. It's double that, right? So what is making this double again? That will be the effect caused by the other reactant, ClO minus 1, because that is doubling. So by factoring in, this is much harder to, by factoring in the order of a reactant you already know, it's, if you double that, the rate will become 4 times, and you figure out that it's 1.024. So you factored in its effect. So उससे आगे जो effect होगा, that's going to be caused by ClO minus 1. So since the rate is again, it's actually double the one that you calculated. So that must have been caused by ClO minus 1 because that's doubling. So same proportion, that means this X is order 1. Yeah, that's order 1. So you can do this directly. We're going to practice this a lot more. You don't get a lot of questions like these. ठीक है, वो जो पहला वाला किया था ना, you get a lot of questions like those. You've got 2 ways you can solve this. You can either solve it by just looking at it, okay, and you can factor in the effect of the order of the reactant you already know of. Or the other method is that you can't factor in what this is doing to the rate. I mean, you can't find a relationship, but you know what the order is. You can solve it simultaneously, and you will eventually figure out what the order is if you solve the 2 equations simultaneously. Okay. So, ये clear है? Is this clear? Hala clear है, Baba? Is this clear?
Yes, sir.
आसान वाला पहले एक कर लेते हैं. I guess मतलब ये भी आसान वाला नहीं है क्योंकि इसमें प्रॉब्लम ये है कि these two are affecting the rate of reaction, right? Well, the trouble is you will not be able to figure out the order with respect to H2O2 because if you double this, there's going to be an effect on the rate of reaction, but the problem is you have to keep the other reactant constant. So again, इसमें वही problem होगी. We'll do this one tomorrow then, ठीक है? So again, next class में we'll practice more of these questions. लेकिन इसमें ना इसका order आप पता कर लोगे बड़े आराम से because you can, I mean, these two are kept constant, right? I mean, these are being kept constant. So this is doubling. What is the effect on the rate of reaction? वो जो factor है, you're going to figure out the factor by taking this number and dividing it by that number. ठीक है? If you do that on your calculator, it's going to come out to be 2. इसको वैसे गौर से देख लो. It's you can take this number and divide by this number. It's actually double of that. So that clearly means that this relationship between AuCl3 and this is order 1. It's directly proportional. So एक का तो पता लग गया, it's directly proportional. The other one you can solve by making simultaneous equations. लेकिन वो फिर हम कल करते हैं, ठीक है? चलिए, ठीक है everyone. tail off is.